Hey everyone, to start off the integration technique series, we'll begin with something very simple, integrating constants and integrating using the power rule. So let's start off easy, integrating 0 dx. Alright, integration is the opposite of differentiation, so let's think of it from the differentiation point of view. What function, after we differentiate, would give us 0? Simply put, what function has gradient 0? So basically it's the horizontal y graph, right? Therefore, there are also actually infinitely many solutions, and to represent that solution, we write it as a constant c. In integration, we use the letter c as a way to represent that there are infinitely many solutions to the integral. Moving on to another example, non-zero constants. So let's say I have a constant 2 and I integrate it with respect to x. Similarly, using this thought process, what function would give us a derivative 2, aka what function has a gradient 2? So we first thought would be, well, my linear graph y equals 2x. But is this the only answer? No, right? There are other possible answers such as 2x plus 1, 2x minus 1, 2x plus pi, and 2x minus e. Basically any constant, correct? And because of this, the answers only differ by a constant, but the thing that remains the same is 2x. And to represent the infinite many possible constants, we again use the letter c. Moving on to power rule, integrating x dx. So again, going back to the thought process, what function has a derivative of x? If you recall from your differentiation, there's this thing called the power rule, right? Where we have x to the power of n, and you differentiate it with respect to x, we would give us, well, bring down the power to the front, we reduce the power by 1. And this is how we obtain x in our final solution. However, in integration, it's the opposite, right? So in differentiation, we bring down the power, aka times the power, and then we reduce the power by 1. Integration is the opposite. We'll increase the power by 1, and then we would divide by the power. So opposite of multiplication is divide. Let's apply it to this example. So x to the power of 1, right? So we increase the power by 1 first. Increase the power by 1. Now we divide by the power 2. And then obviously there are many possible answers, infinitely many possible answers, and we represent it by a plus c. You can check your answer though for your integrals. What do you do? Just differentiate them with respect to the variable. So if I want to check if my answer is correct, what do I do? Well, I differentiate with respect to x. So let's use this example for instance, the integrating x dx. So my answer is x squared over 2 plus c. If I differentiate x squared over 2 plus c, well, bring down the power to the front, right? So I get 2x over 2. Differentiating a constant gives back 0, and I notice I'll get back x, which tallies with the integral. Alright, so we know that the power rule holds true for now. Look at another example. If I have 1 over x squared, it still works, right? Increase the power by 1, which is minus 2. It's minus 2, not plus 2. So it's minus 2 plus 1, so it gives back minus 1, not minus 3. Okay, so don't trick yourself. And then I divide by the new power, minus 1. So basically just add a negative sign, and again, plus your c. This also works for any rational number. So it could be fractions, it could be any rational number, right? So any real constant will work as well. For example, I have 5x to the power of, let's say, pi dx. Alright, so obviously pi is not a rational number, but I could represent this as a irrational number, but thankfully there's a way to represent this irrational number. So again, I increase the power by 1, and then now I divide by the power, and obviously adding a plus c. However, this doesn't work for powers of minus 1, right? You notice if I were to integrate this using the rule, right? Let me just change to the black pen, okay? If to use the rule, right? Okay, increase the power by 1. Minus 1 becomes 0. Okay, x to the power of 0, aka a constant. Divide by the power, hold on, I'm dividing by 0 plus c. Okay, obviously you know that this is wrong, but some of you might think, okay, just, you know what, let's just avoid it. Let the answer be C. But you notice, if the answer is C, what's the issue? There's a problem, right? Because if your answer is C, then it will be 0. Correct? So this rule doesn't work for x to the power of 1. X to the power minus 1, sorry. Because you cannot divide by 0. And in fact, if you notice, this is a very familiar form, right? Because this will actually give you ln x. But I'll go through that in another video. So to sum up, we have the power rule, right? So power rule in integration. Alright, basic one. We haven't even talked about like algebraic functions yet, so don't worry. So power rule in integration, we have integrating x power of n dx equals to increase the power by 1 first, divide by the new power at the constant c. Alternatively, you can represent it as n power minus 1, and then you increase the power by 1, giving you back n, divide by the new power plus c. It works the same, just that from here, power of x cannot be minus 1. And there we have it, the power rule for integration.